Hello, friends. Welcome to another ATC Double Cut. Today, I am joined by my friend Brian Whitlark, who is the regional director of the USGA Green Section in the West region, where I'm from. Welcome to the show, Brian.
Thank you, Micah. Glad to be here.
Looks like you're joining us from the road, which I know a lot of your work involves travel, doesn't it?
Quite a bit. I'm in lovely Palm Springs this week and had a nice, cool week of weather here. So I appreciate that because there's not many more days like that over the next few months in
Oh,
Palm
yeah.
Springs.
That's good. Yeah, it's been hot in Thailand, and I had a towel here that I was wiping the sweat off as I was trying to keep the sound down in my recording studio here, with no air conditioning and no fan. But finally, I relented and turned that up a little bit. So hopefully, I don't have sweat dripping off my face. So I asked you to join me on this show, and I'm so glad that you could, because I wanted to talk about something that we both have quite an interest in and have been doing a lot of thinking about and working on, and that is soil organic matter or soil organic material and the testing of that in the soil. And I wrote a blog post a couple weeks ago, and I'm going to bring that up on the screen. I don't know if you've seen this. It has a title, Organic Matter Terminology in Turfgrass Soils. And I'm making a proposal that we use two different words. Did you read this post yet?
Yes, I have.
All right. So we have not corresponded about whether you agree with me or if you have a different idea, or I I mean, here's here's my thought on the matter. I think turfgrass managers customarily think of anything that's organic, we would consider it soil organic matter because it's obviously organic. So if it comes from the plant, it's organic. But when you start thinking about what gets tested at the lab, those procedures are developed by soil scientists, or they have been developed by soil scientists. And soil scientists are wanting to test the soil. And when they are testing the soil, they want to make sure that they exclude anything that's not soil. And so to
Mhm.
do that, samples get passed through a screen before the soil organic matter is measured. So, what is soil organic matter? And I put a picture of this in the blog post. It's what gets measured on a sample that's been crushed and passed through a 2 millimeter sieve. So, anything that's larger than a grain of sand, which would be a lot of stems and thatchy material and roots that haven't decomposed, and things that are obviously organic in nature, but they're not measured as soil organic matter. You know that. You used to work in laboratory
Mhm.
testing before the USGA, didn't you?
Yes. Yeah. So um, in our study that's sponsored by the USGA, the researchers kind of looked at different ways to handle the samples once they arrived at the lab. And not surprisingly, Micah, the organic matter was significantly different if you sieved and crushed the sample like you suggested. So I guess you're proposing to, perhaps call this, total organic matter material. Is that
Yeah.
accurate?
So what I'm proposing, and I have to say I've been very inconsistent about this over the past 5 or 6 years when I've been advocating doing the OM246 testing, and OM246 stands for organic matter or organic material at the 2, 4, and 6 centimeter depth. So it's that's what that hashtag is all about. But I've used interchangeably, I've used the words organic matter and organic material. And even now in 2023, I still find when I'm talking with turfgrass managers, it seems to me that a lot of people don't make the distinction. They don't know what's happening to the samples at the lab in as much detail as I wish everybody did. And in fact, there's an interesting thread on TurfNet right now on the turfnet.com forum. And I've been looking at that and there are some golf course superintendents talking about whether they can get away with not coring or not, and they're talking about testing for organic matter, and there have been recommendations to do OM246 testing. There have been people doing ISTRIC testing, and there have been people testing at other laboratories, and people are using the word organic matter, organic matter, organic matter testing. But I'm sure that at least two of those laboratories, what's being tested is excluding some of the thatch. But if you're
Yes.
talking about getting away from coring or adjusting your sand top dressing significantly, I think what you need to test is something that includes all of the thatchy material. So it
I agree.
occurred to me maybe we should just use different words. What if we just have two types of organic material numbers that we're looking at. One is the traditional soil organic matter, which is a very valuable number because that's something that we can use to look at soil carbon storage, and we can look at that for nutrient supply, nitrogen mineralization. You have other
Mhm.
elements like sulfur and phosphorus will be mineralized from the soil organic matter. That soil organic matter is something that will also help with water retention, and that's something that usually in a soil that's about 4 inches deep, it would be common in a sand-based root zone. That's going to be something that's 1.5% or something like that. And then in a
Right.
fairway soil, that number is going to go up to 3, 4, 5. The less sandy your soil is, you might get it up to 7, 8% or something like that in a very healthy, mature, 20 or 30-year-old soil. But total organic material, I guess another reason why I want to, and I'm sorry for talking too much. I'm going to be
That's fine.
quiet I and and let you talk. But we've talked about this before, and I have a lot to say about the matter. Also, I find as I do this OM246 testing for more and more clients, there are people that get the result back, and the result is 7% organic material, total organic material in the top 2 centimeters or the zero point 0.8 inches. Or they'll get 8% or 9%. And they write to me after, and I say, do you have any questions? And they write and they say, well, that was a lot higher than I expected. I thought that with all the work that I've been doing, I didn't expect my numbers to be that high. But actually, you shared with me recently what the averages are, and they're right in that range. They're 7, 8, 9% is normal, and that's similar to what I've found also. So to me, I find people seem a little bit surprised at what these total organic material numbers are, and I think because they have a frame of reference that is going to be related to their soil organic matter numbers, which might be 1.5%, which is a
Mhm.
totally different measurement. And I thought, instead of saying organic matter, organic matter, organic matter, why don't I try to be more consistent with making this two different words, and maybe some other people would get on board with that too, and we could make it more clear to people. So
Well, I could support that. For me, I guess I'm not as concerned about the terminology. If we want to call it total organic material, I could certainly support that. But to your point earlier, Mike, I think it's all about, for me, the important thing is, well, first of all, let's all sample the same way. Let's sample the greens the same way. Let's use the same diameter sample. Let's get on the same page with how many samples you need to get an accurate representation of the organic matter in that putting green. And then, secondly, let's have an ASTM standard that suggests that all the labs treat the samples the same. And then we can compare organic matter, total organic material.
yeah,
Uh,
you see,
at
it's very
P3
difficult. It's
yeah, because we're so used to saying organic matter, but
and so. so am I. And I find myself saying it all the time. And yet it's only clear in my mind what I'm talking about. But when I say that word organic matter, I then have to add on another sentence or two explaining which type of test I am talking about, which is why it's wonderful that the USGA is funding this research project to make a standard procedure for testing this other way of testing organic matter, which I propose we call total organic material. Because if we get in the habit of doing that, I don't, it's more efficient. I no longer have to add on two or three explanatory sentences saying, this is the one that's like the OM246 test. This is the one where the sample gets treated at the lab as it's received. It does not pass through a screen. It includes the thatch. And if I say organic matter and then have to add on all of those explanatory sentences, it it's not efficient, although I've made myself clear. But if I could just say total organic material and people understood that that means right, that's the test that measures everything. And then I can just say soil organic matter and everybody knows right. That's the soil organic matter test that's been a standard for 80 or 100 years and everybody knows what that is. So I'm
I
certainly
think
going to try to use this type of terminology. We'll see see
I
how
think
how
people are
effective
catching
that is.
on. You know, we've done samples. We're on the cusp of 1,000 samples from Green Section agronomists now in 3 years, and so some of these are repeat golf courses that they get it now. Whether we call it organic matter or total organic material, they understand that we're leaving the verdert on the top, and they understand that the numbers are very different than what they've been looking at historically by taking that verter off. And you mentioned earlier, Micah, that you want to leave that on the thatch and the verter on because you want to give people actionable information about optimizing their playing surface,
Mm-hmm.
right? And I think that's what's so unique and so helpful about this technique versus how we've done it in the past by removing all that material. Now we're providing recommendations on how to manage the surface to not only optimize turf health, but optimize the playing surface, whether you're looking for really firm greens. And so there's courses out there that want to provide sort of championship conditions as often as they can. And while the organic matter content in that top 2 centimeters, that top 8/10 of an inch has such a big influence on producing firm surfaces.
Mm-hmm.
So that's been fun, really fun for me, is to use this information to help courses develop their aeration program, develop their sand top dressing program, adjust nitrogen inputs, and even adjust watering, irrigation inputs based on that data.
Yeah, it's something that I I don't know how I overlooked this for so much of my earlier time in my career, and it wasn't only me that was overlooking this. And even when people from New Zealand were doing this on a regular basis and publishing about
Mhm.
it and saying, "Hey, here's the data." And people in England and Scotland were doing this type of testing and saying, you should be doing this, and I was just kind of blind to it. I didn't really see the value until I did, and then I started doing this in I started thinking about it in like 2015, 2016. I was like, I really need to start doing this. 2017 I started doing it and started doing my own research program about this, and we talked about it in maybe in 2018 a little bit, in 2019 a lot. um,
Mhm.
and and then you started that project with the USGA in 2020 or 2021, and it's been going like gangbusters, where now I'm doing lots of sampling, you guys are doing lots of sampling, and now we look back on it and say, why why did we go for the past 20 years and not do this?
Yeah, I would look at chemical tests. Micah, and the chemical soil test would always include an organic matter number. And to be quite honest, I never even really looked at it because it didn't factor into my recommendations. I sort of dismissed it. But yeah, what a whiff that was.
Yeah. So and then, so we've, Dr. Caro did that research, which I think a lot of that
Mhm.
was USGA funded also in the late 90s and early 2000s. And he identified that the failure of creeping bentgrass greens, some of that summer bentgrass decline, he associated that with high organic matter content at the surface of sand-based putting greens. And then from that, there was a lot of recommendation of minimum amounts of sand top dressing that should be applied to prevent that problem, minimum amounts of surface area impact from coring or other cultivation. And so that kind of came out about 25 years ago. And then we started doing all of that work and we were never checking it because when you don't do the testing to find out how the organic material is changing at the surface of the greens, you're just doing all of this work but you're not really checking it in terms of what the impact is. Now, with this type of testing, we can see if you're putting sand, enough sand to make the organic material right at the surface go down, if it stays the same, or if it goes up. And so by seeing how the organic material changes, you can then adjust your coring, your top dressing, your irrigation, your nitrogen, and so on to get it in the place that's going to produce the desired playability and the desired plant growing conditions at your facility. It seems
Yes,
like so simple and a no-brainer.
right. Yeah. No, I agree that Dr. Carroll's work kind of got that raised awareness and interest of that procedure. But again, everyone, the labs all did it differently, and we were sampling it differently. And so now, this group of researchers is, looked at different sample diameters, different tools. Should it be 3/4 inch? Should it be inch and a half? And they took up to 50 samples per green to look at statistically what was required to get an accurate sample. And the good news is, I think we've been using this inch and a half diameter sample, taking 5 samples per green. I think next year we'll be downsizing to a 3/4 inch sample diameter and taking 8, maybe 10 samples per green. And that will be useful because it's a little less disruptive. We can fix that with a pitch mark repair tool and perhaps fill the channel with a little bit of sand. But it'll be easier to take those samples. And so I'm looking forward to a little bit smaller diameter size. And I know
Yeah,
the
that.
superintendents I work with will
Yeah, I
be as
think
well.
I like to use something that is either an inch and a quarter or an inch and a half. I mean, I'm using metric, so I've got a 3 centimeter diameter sampler. 1 inch is
Mhm.
2.54 centimeters. So I've got a 3 centimeter and a 4 centimeter, and people don't like it when the holes are that size.
No.
However, um, I my only response to that would be you if we're only taking 5 plugs per green, we could always go cut those from somewhere. And a 4 centimeter diameter plug is pretty easy to then fix. So we're taking away the sample, but if we wanted to, we could just fix it. But it's a bit of a hassle. So yeah, smaller diameter samplers would be uh, easier to fix if you could just fix it like a ball mark.
Yeah, and I'm confident that the researchers are going to suggest that. And
So
and if the
right, so
superintendents that are listening, oh, go ahead, Mike. I'm sorry.
yeah, thank you. That's what I was going to ask. I appreciate you sharing this. Can you tell me everything that you can about what the results have been in terms of what the method will be for sampling?
You bet. Yeah. So for the superintendents that are listening, I think I'd recommend going ahead with the 3/4 inch diameter sampler. And it's been interesting. The higher organic matter you have, the more samples you need to get an accurate representation of the organic matter in that green. In the work that Doug Soldat and the group have done, they range the organic matter in that top 2 centimeters, the total organic material in that top 2 centimeters ranged from as low as about 4% up to about 17%. And they found that as the organic material increased, you needed a bit more samples to get an accurate representation. So they're going to I think they're going to recommend about 8 samples with the 3/4 inch diameter tool to get an accurate representation. So that's not too bad, and those are easy to fix. So for those that are listening now, if you're interested in taking these, I'd say go ahead and use that 3/4 inch diameter tool, but take at 8 samples per green to get an accurate representation.
And do you have a
For the
recommendation for the number of greens?
um,
Every
so
green?
we're taking 3 greens per golf course. For some, I've only done 2, but I like to have a third green. Some courses have gone on their own and taken 9 to 10 or up to 12 greens per facility. That's been really interesting. Those courses, um, they're interested in looking at sort of the weak greens and the really healthy greens, and then some in between. And that's been really interesting and kind of leads to another discussion, Mike. I don't know how much you want to get into a little bit of a side discussion, but I'll just say this: in addition to taking organic material from the greens,
Thank
we're
you.
all
Yeah, see, this is
we've also
catching on all
been
right. We're only
taking,
20 minutes
yeah,
into this,
yeah,
and you're
we're gonna
already using the right terminology.
so we've been taking shear strength, and there's a tool that Turf Tech sells that where you push this tool. It has these little small diameter blades, and I don't know, there's probably 20 of them in a circle. The diameter is probably about 3 inches, and you put this into a green, and the blade depth is about an inch. So you put this down into a green, and then you equip a torque wrench to this, and then you just turn it, and you measure the force required to tear the surface of the green. And it's been really interesting because the courses that really want to produce firm conditions, they've been striving for very low organic material numbers, right? And some have been in the very low range, about 3.5% range to maybe 4%. And when we collect firmness numbers, yes, those greens are always firmer than greens that have higher organic matter. Okay. However, when a ball comes into some of these greens, it impacts the surface and the surface just kind of blows up. So the ball reaction isn't what you would expect from a green that's yielding a firm surface reading.
Hmm.
So, and we would sort of take a pitch mark repair tool and, fix ball marks, and we could just subjectively note that, the surface of the green is kind of weak. So we decided, well, let's put a value on that. And so that came about, this shear strength testing tool. So some of these greens were getting firm readings, yet the shear strength test, and this is measured in Newton meters. Some of these greens were in the single digits. They would be 7, 8, 9 Newton meters, which I can confidently say now after using this for a little bit that's a weak green. And that green is at risk of really damaging ball marks and damage from traffic, walk-ons and walk-offs, that sort of thing. So while these superintendents were sort of over aerating, under fertilizing in search of these low organic matter levels, they were creating a weak conditioned green, a green with weak surface strength.
Hmm.
So that's been interesting, really interesting. It's another factor in our recommendations. So it's not only let's strive for a certain organic matter range, but also we need to optimize the surface strength of the green as well. So that's another component to this. And sorry to veer off the organic
Now
matter.
that's very interesting, and it reminds me of something. I happened to have a discussion with Richard Forsyth, who's the director of courses at Royal Melbourne Golf Club. I had a conversation with him yesterday, and that's on a different show, the ATC Office Hours. I'll share that link with you, Brian. You can listen to that on a
Yeah,
drive sometime, and I'll put a direct link to this in the show notes and in the video description so people can check that out if they're interested, because Royal Melbourne Golf Club is renowned for really firm greens, and they do a very interesting process to manage their organic material that builds
nice.
up. And what they do is and we showed some pictures in that discussion yesterday. They take a sod cutter, they cut a very thin layer of turf off the green. Now this is about once every 10 years. It's not annually. They cut it off, and I'm getting to the punchline here that is going to match with what you shared, Brian. Uh, and then so they roll up that very thin turf, the grass, with very little organic material beneath it, and they put that and they save it because they're going to put it back down. They then run the sod cutter again and they check on a green by green basis how much material, how much organic material do they need to remove to get back down to that original sand belt sand. And it's usually about the height of a golf ball or something over a decade. They run the sod cutter and cut those pieces, and they load it onto front end loaders and haul it away. Now they're back down to original sandbelt sand. They graden it, they rake it smooth, and they put the grass back down. And now it's just right on sand. And you know what Richard Forsyth told me? He said the bat. He said they're firm right away, but he said they don't get the proper kind of firmness to where the ball hits and bounces upright until about the third year after doing that. When the roots have come down and anchored in, when the organic material has actually built up a little bit. And I thought that was very interesting. And I think we're on to something here of moderation in sand top dressing and moderation in cultivation. And I think the pendulum had gone a little bit in the direction of put down as much sand as you can, cultivate as every chance you can get. And there's so much technology in terms of machinery that's out there that allows us as turfgrass managers to be able to do that with, minimal disruption to play. And a lot of people have techniques that allow them to put a lot of sand out, but if you can actually put too much, and you can put too little too. It's not all about like doing less. There's a lot of places that need to do more. This type of testing, the what I call OM 246 and what the USGA might call total organic material testing. Do you guys have a name for this? Or you just say, hey, we want to come take some of these organic
We've
matter by
just,
depth
I have to
samples?
admit, we've just been calling it our organic matter. But to your point earlier, for those that are new to it, we do describe, what the process is and what it looks like. And
Yeah.
then, to expand on your question about talking about this testing and what I can tell you about it, some recent developments, Micah, Brookside, as you know, tests, they burn. Well, they first dry it at 105 degrees Celsius for 24 hours, right? And then they ash it in the muffle furnace at 360 and 440 degrees Celsius. So there was concern among the researchers that that 440 degrees would burn off some carbonates, calcium carbonates for those greens that are calcareous, right? So recently they took a look at that and they found that it wasn't until about 900 degrees
Hmm.
Celsius that they burned off the carbonate. So I think the research group is more comfortable with that higher temperature. And in fact, now that after seeing those results, they're actually going to look at some temperatures above and beyond the 440 to determine what perhaps what is the best
Yeah,
temperature. And I know you've done some nice work on that, taking some pictures and
yeah, I've done all of this with fewer samples than you all have. So I've done the same like variability, like what the sample volume should be, how many subsamples you should take to get a reproducible number. Um, I've done all of this. I just haven't published it, but it's just all on my computer. But you guys are doing it at a much larger scale with a much larger sample size. I've I've just read about what the threshold numbers are to burn gypsum and burn. So if you got gypsum in the soil, you burn that at I think 500 or something. Calcium carbonate, you'll burn that also. It's something above 500 Celsius. So as long as you stay under 500 Celsius, I'm happy. I've done what I do now with all my OM246 samples is a single burn at 440 because I don't see any value. I checked what the 360 and then a sequential 440 burn after that, and they're correlated with a R squared of 0.99, which means I saw no extra information from that. It was just a higher cost lab test and more work for the lab, and really I wasn't getting extra information from that I could use. So I said, can we just burn it at 440? And it's not because I get a better number from 440. The reason is because the sample looks the way I want it to look. Because the whole point of this test is to burn all the organic material. I went to the lab I've been to Brookside Labs 3 times. I've spent a lot of time in labs, especially in graduate school, but not so much with a muffle furnace. And I went to Brookside in 2018, 2022, and 2023 to go look at the process, see what samples look like prior to and after the burn. And after a 360-degree burn, the samples, some of that organic material looks black. It's ashed. It doesn't weigh anything to speak of, but it doesn't look the way I want it to look because the whole point of doing this testing is to burn off 100% of the total organic material. With a 440 burn, you get 2 types of ash that I've seen. Most of it is just a white ash that once you put a spoon in it or stir the sample, it disappears. It's a white ash that just turns to a powder. It completely disappears in the sand that remains. And there's another type of ash that looks like it still be some organic material there. It's these little balls of dark material. But I've taken that and I didn't get a good video of that. And I wish I had because that's just an ash that just turns into it's just the finest possible powder like ash is, just right in my hand. And so I'm confident that there's no more fiber, no more organic material left. It's all ashed at 440. So for me, I like the way the sample looks at 440. But I was speaking with the lab manager, and the tolerance on these type of methods is usually like plus or minus 40 degrees anyway, something like that. So it's sort of like, the muffle furnace, it's not doing exactly 440 for the entire time. That's pretty hot, and I think these machines are a little bit crude.
right. Well, we see the same thing, Mike. I think RR squared was 0.9999 with the 2 different temperatures, and it's about 10% higher we see with the 440 versus for the 360. And like you
Mm-hmm.
said, one number, I don't know,
But
you could argue whether one number is better, but I'm with you. If we're going to look at total organic material, well, let's burn as much off as we can.
yeah, and so I'm comfortable we're getting that at
Yeah.
440, and but yeah, it's awesome you guys are checking it more. So yeah, I just think I hope the method that the USGA research team comes up with uh, is not so different than what's done in New Zealand, what I do with OM246, and what they're doing in the UK. Now, as far as I know, in New Zealand, they cut the golf course superintendent will collect the sample, send it to the lab. At the lab, they'll cut the grass off. So they're cutting off the verdure, the above ground green matter, the above ground plant material. I don't think that's a good idea for putting green samples because it tends to be intermingled with sand. So you end up destroying some of the material that you'd want to be measuring, and you're sort of like mutilating the sample. It doesn't make sense to me to do that.
Yeah,
Plus
I
the golf
agree.
balls, plus the golf ball is reacting with that. I've done comparison of verdure on and verdure off from paired samples, and it's about 0.5% increase by leaving it on.
Right.
So
And not only that, there's more air involved. So this research team found that there was less air when you left the verter on. So if you're cutting it, well, there's a human element there, and not everyone's going to cut it the same. So it was more accurate um,
mm-hmm.
by just leaving it alone.
Yeah, I,
Yeah,
that that is, and it's faster, and yeah,
yeah,
it's, and even if there's not more error, there's more doubt in my mind, because if the samples ever came back with an unusual result or an unexpected result, I would wonder, did the verdure get cut off in a weird way? Because I just top dressed 2 months ago. Did that sand suddenly fall out of the sample? Did that not get counted? And it very well could have not. It could get knocked out of the sample if they're cutting off the very top of it. So
mm,
but the way I understand that they do it in New Zealand and in the UK is to cut that off, which the what OM246 differs from those methods is we don't cut the top off. And the USGA has continued with that in your research, and you've also verified that seems to be a reasonable way to do it. And then as far as the sample diameter, the sample temperature, the total amount of material submitted, it sounds like we're all kind of on the same page about how it works to do that. So
yes. And then,
that's good.
one thing that the research team is looking at this year is how does it change seasonally? Should you test in the spring or the summer or the fall? So they're actually taking samples every month and just looking at how the organic matter changes. I've done some of that, where I've sampled um, certain golf courses several times per year, and we absolutely do see a change from spring to fall. So it'll be interesting to hear where they arrive at a recommendation for seasonal changes. What do you think about that, Micah?
I don't like sampling mid-season. That's for sure. And the reason I don't like sampling mid-season is you just the rhizomes might be different. Yeah, you'll have different root structure. We're measuring the
Mm-hmm.
living and the dead plant material with this total organic material testing. I like doing autumn, and then if we're in a tropical place, if we're in Florida or something, I would probably do it in the end of winter, because you've got most of the cultivation is going to happen in the late spring, summer, early autumn. So if I was in Florida, or the type of, maybe in in Palm Springs or Phoenix, that type of climate, I'd be doing it probably late winter, just because you're right. But for temperate regions, cool season grass, I like to do it end of the season, because now you can see, here's the effect of all the work that we did this year. You're looking at, here's how much the grass grew and accumulated organic material. Here's how the microbes and the weather that we had caused the organic material to decompose. And here's the effect of our top dressing and dry ejecting and core removal and all of that. So
Sure.
those are, and some people will want to send samples in July or something, and sometimes we do get numbers that come in, uh, and they're a little bit different, and then it changes 2 months later when we test again in September or October, and I'm like, is that a real change, or is it because the roots
Right.
grew
Right.
more over the past 2 months? I really don't know the good answer for that. So
Yeah.
I'm like, I like to compare season. I mean, compare October to October to October.
Yeah.
If you sample in October.
Right. Yeah, I think it's important to sample the same time of year. For some courses that are, again, for those that are really trying to produce firm conditions, uh, it's been fun to work with them, especially because we've been sampling those golf courses in the spring, and they'll actually kind of wait for the results to determine what they're going to do for as far as aeration and sand top dressing. They really rely on that information just to schedule their plan for the year.
Well, I think it's a good thing to rely on, or a good thing to reference in addition to other things that you may be referencing. But I prefer to do my nutrient testing in the autumn also, with a few exceptions. But I like to do everything in the autumn for places that have a winter and then a summer golf season, because it gives you the entire winter to make the plan. I think springs are so busy. I don't like to do nutrient testing or OM246 testing in the spring, because you're in such a hurry to get the results, and then you're already into the, prepping for the peak season, and you're trying to adjust. Oh, my organic matter went up by 2%. Sorry. See, you see how difficult this is. My total organic material went up by 2%. So now I need to fit in an extra heavy top dressing. Isn't
Right.
it easier to plan for that if you know that number on October 15th instead of you're finding it out on May the 1st?
Sure. Yeah,
So,
I think that's accurate. As far as been, the USGA agronomists have been taking the samples, all of these samples, so we can't go to all the courses at a certain, in October.
mhm.
But as once this research group makes this recommendation, then I think there'll be a lot more courses that take their own samples, and like you said, then they can take them in the fall, and then I'll make that recommendation. So I appreciate that feedback.
Yeah. Well, I think, yeah, if anybody's listened to the show for this long and still has any confusion about what we're actually talking about, can both of us try to summarize the distinction? So if I summarize in my words and then you just summarize in your words, what is so unique about this type of testing, and what is the fundamental or the main differences between this and what has been done before, or what is new about this type of testing, just to try to make it as clear as possible if anybody still has any doubts about it. I think that would be a wonderful way for us to close this
Okay.
discussion. So, do you want to go first, or you want me to go first?
Well, I'll take a stab at it. So I would just make 2 points. Number one, this testing is different because I hope it to be a global standard. So everyone collects the samples the same. When the samples arrive at the lab, all the labs handle it the same. So everyone can compare results, whether you're in New Zealand, United States, Thailand, wherever. So that's number one. Number two, this is different because historically you would sample only the dead and decaying plant material or organic material in the soil and remove all of the verdure off the top. And typically that was a sample that's collected down to a 3-inch depth. So historically, that's kind of what's been done. This is different in that because we're testing the total organic material in the top 2 centimeters, 2 to 4 centimeters, 4 to 6 centimeters, and we're leaving the verdure on the top of that 0 to 2 centimeter depth.
Wonderful, Brian. Thank you so much. Now, I will explain it. What I think is so distinctive about this type of testing is that the sample gets sent to the lab and it's been collected at very specific depths, which is different from conventional testing, where we're looking at nutrients in the entire root zone generally. But this type of testing is done, I recommend it at 0 to 2 centimeter, 2 to 4, and 4 to 6 centimeter depth, which is 0 to 0.8 inches. So it's in 0.8 inch increments. So one thing is that it's by depth, but the main thing is when this gets to the lab, you've sent a sample and the lab does not do anything to turn it into a soil sample. When you send a regular sample to the lab, and I've got a video that I will put a link to that shows what happens to a sample as it goes to at Brookside Labs for a soil nutrient analysis. It first goes to a drying room, then it goes to a grinding room, and then all of the undecomposed living and dead plant material gets removed from the sample and gets thrown in the bin. And the soil that remains is what goes on for further testing in the various laboratory rooms and on the various instruments. The OM246 testing, the total organic material testing, the lab doesn't do any of that processing. They burn the sample and measure 100%, which is why they're measuring 100% of the total organic material, which is why I think it makes sense to call this total organic material and refer to soil organic matter as soil organic matter. So, yeah, that's not quite an elevator speech, is it?
Not quite.
I still have some work to do on making it really clear. But yeah, hopefully a lot of people will get it by now. We've spent 45 minutes talking about a very simple test.
The bottom line is we're testing total organic material to help superintendents optimize the turf health and performance of their grains.
There we go. That's
Boom.
perfect, Brian. Well,
That's it.
yeah, that is perfect. So I think that is a perfect place to end the show, and I'll be back again soon with another interesting turfgrass topic. Thanks everyone for listening. I will sign off now for ATC from Yantikau, Thailand. I'm Michael Woods.